Okay, welcome to lesson 3 of quantitative chemistry, and we'll go through a little bit of what we've done before, but this lesson really is, in the last lesson we worked out for something like hydrogen, how much first of all does hydrogen weigh, and that was the relative atomic mass, and hydrogen, you look on your periodic table, it's 1. How much was the mass of a H2O? And that's one of the ones we did. So you had to take H2O and go, oh, 1 plus 1, there's the two H's, and then you look for the AR of oxygen, H2O, that was 16. So 1 and 1 and 16 makes 18. So 18 had a relative molecular mass of 18. But that's what we have done. What we'll be doing today is looking at the masses. So, first of all, can you try these 4 questions? And when you're ready, press unpause, and then we'll be ready to move on. Okay, so what's the mass of oxygen? You should have put, hopefully, 16. It's the mass number. And when you were asked what's the mass of O2, you would have put 32 because there's 2 of them. What bond keeps them together? Well, because it is a matter of non-metal and non-metal, it's the overlapping sharing of electrons. So the answer would have been covalent. And why is oxygen a gas at room temperature? And that's because the molecules of oxygen are not attracted together. So weak intermolecular forces, some forces between molecules, weak forces, which don't require much energy to overcome. You could have put, because the molecules are not attracted together, so they're free to move around, which is the way a lot of you refer to it. So the relative molecular mass, or the relative formula mass, is the mass, the MR is the mass of a molecule. And we've just done a minute ago, right at the start, H2O is 18. And that's because 1 plus 1 plus 16 equals 18. Sorry about my writing. The drawing pad on this computer, not quite as good. And then before that, we've looked at AR, what's the mass of the atoms, and we've done things like, there you go. Oxygen is 16, carbon, when we did it, was 12, magnesium, carbon was 12, magnesium was 24, and in the last lesson you fill this in for yourself. Straight off the periodic table, the ARs. And then we did this method. Elephants, I'll change colour pen for a minute so it stands out from the last lesson. So the element, the mass, the number of that element, and then the subtotal. And for this one, for CO2, the last thing you did, it has the elements carbon and oxygen. Carbon weighs 12, oxygen 16. There's 1 carbon in there, and there's 2. So in CO2, there's 1 carbon and there's 2 oxygens. 1 lot of 12 is 12. 2 lots of 16 is 32. Add them together, and the answer, the MR, relative formula mass of CO2, is 44. Now percentage mass. So we've just said that CO2 has a mass of 44. how much of that is carbon? What percentage of that is carbon? That's the bit that we're moving on to in today's lesson. So what's a percentage? Well, you all know that a percentage is a fraction, but it's a special type of fraction. Oh, got to write the word fraction, sorry. Right, that's even worse using the mouse pad. Therefore, I'll go back to using this. It's a fraction out of 100. So when we say 50%, we mean 50 out of 100. You know that 50% is a half. So that should be quite easy. You know that 25%, 25 out of 100, is a quarter. So when we want to do percentages, we do the fraction, we do dividing by the total, and then times it by 100. So all we have to do is divide by a total, and then times by 100. So what we have to do here, in the one I've just asked you, is I want to know what percentage of this here chemical, CO2, I want to know what percentage of it is carbon. That's the one I'm after. So, carbon has a mass of 12 and the total is 44. So when I do 12 divided by 44, I'll just give you a few seconds to do that. So 12 divided by 44, what do you get? And hopefully you get 0.27 times that by 100, and I get the answer 27%. And that's what today's lesson is about. How do you work out the percentage of an element in a molecule? Now, why would we want to do this? What would possibly be the reason? So here, for example, one of them is actually a real picture of a mineral containing an ore and a rock containing iron, and you can see there's quite a lot of brownness in here, that giving a good idea there's lots of iron. And here, this is the real world, and this is from a world where you spend a lot of your time, or did when you were slightly younger, and that would be Minecraft world. Ooh. Not much brown in here, so we could say this has a low percentage of iron, whereas the real world one, a high percentage of iron. See if I can find my cursor. Oh, there we are. So the one I just did a minute ago, let's go through it a step at a time. So step one, you calculate the MR, which we've done for CO2. This is the same question. We're just going to formalize it here. Step two, you calculate the mass of just one of the elements. In this case, it was carbon. Step three, divide your answer to step two by step one. So divide your answer. We have the carbon mass over the CO2 mass, and then we times it by 100. And step four, repeat it for any other element you've been asked about, and in this case we haven't. So let's do it in the 3 steps. Step one, you calculate the total. So the total in CO2 is 12 plus 12, no it's not, silly me, 12, go back to my rubber, 12 plus 16 for oxygen, but there's 2 of them, so I have to do a plus 16, equals 44. And we did it a few minutes ago with the EM, so element, mass, number, subtotal. Elephants might not skate from last lesson. So the elements were carbon and oxygen. Then we had the table a few minutes ago, so don't worry about that. Okay, so now we go on to step 2. So step 2, carbon. There's only one of them in there, and that has a mass of 12. Step 3, divide your answer. So this one here, I had 12 divided by 44. Obviously your writing will be a lot neater than mine. Equals 0.27. Then times that by 100 to turn it into a percentage, equals 27%. So what I know is in CO2, 27% of it is carbon. That means 73%, all the rest out of 100, must be oxygen. But the question said, what is the percentage of carbon in carbon dioxide? And my answer, 27%. Getting used to this pen now, it's almost like I can make sense. Okay, so here's a question for you to try yourself. How much, one second, let's choose the right pen. There we go. How much magnesium is in magnesium oxide? So remember steps 1, 2 and 3. Try it yourself and unpause it when you're ready. Okay, so hopefully you got magnesium was 24 and magnesium oxide that you divide it by in total is 24 plus 16, which is 40. And that gives you a total, when you divide it, of 0.6. Then you times that by 100, and then you got 60%. So if you end up with a block of magnesium oxide, you know that 60% of it is magnesium, and therefore 40% of it is oxygen. Okay, this goes through the carbon dioxide example again. Hopefully you've already written that down from earlier. And then, again, this is the step-by-step approach. So step 1, calculate the total of the molecule. Then calculate the amount of one of the elements, the one we're after. So could you write down the 4 steps? And then we're going to do this one. The mass of every element in here. So we're going to start with, what's the total MR? So step 1, the MR of the whole thing. So we go back to our E. Elephants might not skate. And I've got 3 elements in here. I've got hydrogen, I've got sulfur, and I've got oxygen. How many hydrogens have I got? I've got 2. How many sulfurs have I got? I've got 1. How many oxygens have I got? I didn't, 1. And I've got 4 oxygens. So I've got a mass of 1, a mass of 32, and a mass of 16. So 2 lots of 1 is 2. That didn't come out very well. Still didn't, because it's coming up with something else. There you go. 2. And 1 lot of 32 is 32. And 4 lots of 16 is 64. Add them all together, and I get 98. Right. So what I know is, by using this method, if I've got 2 out of 98, that's the hydrogens. If I've got 32 out of 98, that is the sulfur. And if I've got 64 out of 98, that's my oxygens. So all I have to do then is convert them into percentages. So, for example, let's just do one of them for you. You can work out the others yourself. All I have to do, quite easily, hopefully, is 32 divided by 98 is 0.33, times it by 100 and I get 33%. So I know that sulfur is 33% of H2SO4, which, if you want to know, is quite a common formula we use in chemistry, sulfuric acid. Don't worry about the steps appearing. I should have done that as we went along. Okay, now these are for you. So, if you are doing foundation paper, can you please go through each of these ones in an orange box? I'm just going to put an F there for the foundation paper. And what you're trying to do for each one is you're trying to work out what percentage of the element there in red. So we've already done this one. A minute ago we did this one and it was 60% magnesium. But remember to show your working out, because with exam papers they want you to show the steps in the working out, and that's what you get the marks for. If you're doing higher paper, do these ones instead. Again, the red element. Harder to work out some of the MRs. And actually, for those who really want to push themselves, we'd expect to see these ones as well. Okay, best of luck, and make sure that's the work along with a photo of your exercise book that you send to your teacher. Thank you for listening.